Good morning, everybody. Welcome to the Dayton Lamina booth, Fabtech 2025. My name is Duane, and I'm going to give a short presentation about rotary bending tools, the Lamina Posi-Bend units. So let's get right into it. So in the stamping industry, bending sheet metal has been around for 100 years, ever since stamping has been around. And traditionally, the way we did it is we used what we would call wipe tooling, or wipe operations. And it's worked for a while, but like anything, we have technology coming out with different, better ways. And I'm going to go over the wipe tooling and the wipe process briefly, just to give you a quick overview of how it works and why it works and whatnot. So in this illustration, we've got three little steps here in a traditional press. In the first illustration, we were calling it the part hold down, where the press cycles, a spring-loaded stripper or stripper pad of some sort comes down, contacts the strip, and the wipe detail or the wipe punch begins making contact with the sheet metal that it wants to bend. In the second illustration, the wiping action begins. So you can see the wipe detail or the wipe punch continuing to move down, and as it bends the material over the lower anvil, we'll call it, it starts to scrape all the way down the sheet metal. Now this could be a concern if you're bending pre-painted parts or pre-coated parts, or even parts that want to be painted later. So that's gonna kind of become important later in the presentation. So moving over to the third illustration, once the press reaches its bottom and the part is fully bent in the direction it wants to be bent, we have a coining process here where the wipe punch actually coins and hits that material right at the bend and creases it. And this needs to happen in order to set that bend and hold that bend at the angle that it wants to be. Unfortunately, when we do this, we weaken the material at that point. So to achieve it this way, it's an arduous process, and it weakens the material there in this corner. Plus, wipe tooling doesn't really have the ability to bend more than 90 degrees. So it gets very tricky in applications after that. So how do benders work? Well, in this exercise here, I'm going to show you 4 processes of a rotary bender bending that same piece of material in the same type of press operation. Now, here I'm going to demonstrate everything where the rotary bender is mounted in the upper portion of the press. This isn't saying that you can't bend material upwards as the press comes down, but this is going to cover about 80 to 90% of the applications out there. So in the first little illustration, you'll see the rotary bender in position in the upper die shoe, and as it comes down, the rocker portion of the bender is getting close to material, and this is the part that does all the work. The rocker, it rotates as it bends the material. So moving forward into the bend cycle, the rocker makes contact with the material in 2 different points and continues moving down with the press. As you can see, the rocker rotates and continues bending the material over the anvil, and it rolls it. And the beauty of this is we can calculate overbend into the operation so that when the material springs back after the rotary bender moves out of the way, the material is going to spring back, and we can calculate how much spring back is needed to arrive at the achieved bend that you're looking for. So here we show the rocker finishing doing its process, and then as we move forward to the next illustration, you'll see the spring back of the material into the desired location. So a quick overview here of all different types of bends that we can do. We can do square bends and over square bends, channel bends, hats as we call them, Z's and short legs. We can work with your design team and your die setup to interlace benders, stagger benders, and we can get creative to achieve the bend that you're looking for. And these are just some standard ones that we've done over the years and whatnot. But if it can be done, if it can fit in your process or into your die, our engineers are well versed in this to make that happen. So what's the difference between the Dayton Lamina Posi-Bend and other benders out there in the market? Well, first and foremost, it's the gib installation. Our benders are designed so that you can access the gib from die position while the bender is mounted inside the die. Our competitors, they like to fasten them with screws from behind the bender itself, which requires complete removal of the bender, and in some cases, removal of the tool out of the press. Whereas ours, even if the tool is in the press and the press is open, you can access our benders and all the gibs. Remove them. You can remove the rocker if need be. You can for cleaning, for maintenance and whatnot. So accessibility is a big portion here. Second thing is we have improved wear resistance in our benders, and where that is we have a proprietary dry lube finish that we apply in this area of the saddle where the rocker rides. And this dry lube finish, it's applied similarly to how wear resistant coatings would be applied to end mills and drills and even our punches. Similar process but different. So by this rocker riding in there, it certainly extends the life of the rocker, of the complete unit, and it extends the life of the whole program. So what are some of the Posi-Bend commercial benefits? Right off the bat, reduced time, faster setup time, and reduced cost. We have catalog benders that you can buy right off the shelf that can be mounted into your die right away, versus like the manufacturing wipe tooling. And most of that, the old style wipe tooling is done in-house, where now we have something that's commercially available. You can purchase it, put it right into your tool, and with a little bit of adjustment and setup, you're off and running. Less tonnage required versus the old traditional wipe tooling. We've seen, and this is due to the coining process, we've seen benders use as low as 20% of the tonnage required versus wipe tooling. So you don't have to coin that corner using a rotary bender. So less tonnage required equals less force being exerted, less wear and tear on your press and all the components within it, and the nuts and the bolts and things coming loose and all that. So it's just all better for the life of your tool. Faster delivery and superior engineering support. Our engineering staff will work with your engineers, your designers, and we will tailor. If you need a custom bender, we can tailor that bender to your needs. You can send us a part print or CAD files. We can accept just about every CAD format, and yeah, so sorry, I lost my train of thought there. We can work with your engineers and come up with a bender setup that's going to suit your tool and your design and whatnot. Reduced design time. We've got a large library of 3D files already designed, already cataloged, to where you can go to our website, grab a file, drop it, and drag it into your design, and you won't have to recreate the wheel. It's already done for you. It's there. You can drop it right in and move forward from there. Same day quotes on standard products. So with our catalog line of benders, we try to get pricing and delivery information back to you the same day. We strive for one-day quote on non-standard items, customs, made per print, that sort of thing. This depends on the complexity of it and our workload. Granted, sometimes we do get the backlog and whatnot, but we try to get custom type orders or requests looked at and pricing and delivery information back to you within 24 hours. With these benders, we have two styles of bender. We have what we call our standard production bender, and then our high production bender. Now, the standard production bender, that's geared a little bit more towards milder steels, lower volumes, and it comes with a saddle, which is made out of 4140 pre-treated material. It's very machinable. Versus our high production benders, these have a saddle made out of A2 steel, which is fully heat treated, and machined. And the high production benders, these are more towards your high strength steels, your trip steels, or your high strength low alloys, and for programs that run longer, higher volumes. You know, this is very common in the canning industry, or maybe even in the fastener industry. And lastly, we have in-house heat treating. So we do all the heat treating ourselves in-house, and this is a process that we can control. And when we prefer to do it this way because it's not another outside process that we have to depend on somebody else on the outside. All the heat treating is done in-house. We can control it, so that equals faster deliveries and quicker turnaround times for you. So that's a quick overview of the Dayton Lamina Posi-Bend and the Rotary Benders. If you have any questions, don't hesitate to reach out to one of the gentlemen in the booth with the teal shirts, and we'd be happy to help you out with any questions or concerns you might have. And don't forget to come back at 11 o'clock where John Klukas is going to do a quick snapshot of his die clinic and talk about selecting punches. Thank you.